Let's use the ideas from the previous lecture to think about addiction. A very impressive and rapidly growing body of research in neuroscience has shown that one of the salient characteristics of drugs of abuse, like cocaine or crack or nicotine or even alcohol, is that with repeated use, the brain develops a tendency to engage in drug-seeking behaviors that do not necessarily generate pleasure. Now, this is quite puzzling. Why would people choose things that they don't end up enjoying at a hedonic level? And how do we think about it within the context of consumer theory? So here is a very simple way of thinking about how to model this. You could imagine that the true experience utility function over goods X and M is some benefit function X plus M, where X denotes the level, the amount of drugs that individuals consume. However, as individuals become highly exposed to the substance, as they have consumed a lot of the drug, it may be that the decision utility function that is consistent with the generation of the behavior is not this, but theta bf of x plus m, where theta is a parameter that is much, much greater than 1. And you could imagine that theta increases with the history of use. So in this particular case, there is a gap between the decision utility and the experience utility. Now, what's the implication of this? Let's look first at behavior. And for simplicity, let's focus on interior solutions. Now, we know that if we look at this diagram, the optimal behavior is going to be determined at any price. So let's suppose that this is a price by the intersection of the price curve and the marginal benefit function, but for the experience utility. That's what determines the optimal choice. The problem is that the subject is maximizing this decision utility function, and therefore its actual behavior is going to be determined by the intersection of the price function at the marginal decision utility that is much higher. So that is what we have as a choice at P, which of course is much bigger, and that's the source of the mistake. Now, let's think for a second about what does it do for consumer surplus, for the true consumer surplus given the behavior. So the consumer that is addicted is consuming at this level, which is much higher than the optimal. Now, what's its level of well-being? Let's think about it. He's consuming from here to here. The integral under the marginal benefit curve says that he's getting all of those benefits that I'm highlighting here, but he's also paying all of these costs. Okay, so maybe let me draw that. It will be easier for you. In gray, I'm drawing the cost that is paying, and in green, I'm drawing all of the benefits given its true experience utility function that he's getting, which is the area under that integral. Now, what is the net consumer surplus, where we have to subtract the green minus the gray? So this becomes positive, these two cancel, and this become negative. So if I call this B and I call that A, the true consumer surplus is going to be equal to A minus B. Now, it's very easy to see that depending on the details of the parameters, and even as drawn here, this may be negative. The true consumer surplus generated by the mistake may be negative. The consumer would be better off if he were to be stopped from consuming. So this is an example in which prohibition, a prohibition that works, can be welfare improving. Now, let me emphasize that that depends on the parameters. It could be the case that, for some values of theta, for some values of the benefit curve, the area A is greater than the area B, in which case it wouldn't be the case. Prohibition would be worse than just letting the consumer choose freely and make some small mistakes.